بسم الله الرحمن الرحيم. Last part we spoke about the Newton's difference or divided difference interpolation. And we said that the Newton's divided difference operation or interpolation is based on the difference operator, where the difference operator is given by delta Fi is equal to Fi plus 1 minus Fi. This is the difference operator, and for the divided difference, is given by xi plus 1. It is just the difference operator divided by the difference between xi and xi plus 1. This f of I plus 1 minus f of I divided by xi plus 1 minus xi. Or just can be written simply as delta fi divided by xi plus 1 minus xi. And this is the, it should be sub I. Small one. Minus xi. This is the divided difference. It is difference operator divided by the difference between the values xi plus 1 and xi. Now, if the differences between xi plus 1 and xi are the same, are equal, if xi plus 1 minus xi is equal to h, is constant. No change. It is the same in all the partitions. So the point will be given as x0, x1 is equal to x sub 0 plus h, x2 equal to x sub 0 plus 2h, and like this up to x sub n, which is equal to x sub 0 plus nh. In this case, when the difference operator applied k times, that will be defined as delta of k minus 1 of I plus 1 minus delta k minus 1 fi. This will give me the divided difference x0, x1 up to x sub k can be written as 1 over k factorial times h to power k multiplied by delta to power k, or applied k times at f0. So if we have equally spaced partition, then I can write the divided difference in this formula, in this form. 1 over ki h to power k multiplied by delta of order k applied to f sub 0. So in this case, the Newton's forward difference will be written as forward difference interpolation. Given by f sub x or f of x can be approximated by Pn x, which is equal to f sub 0 plus r delta f sub 0 plus r times r minus 1 divided by 2 factorial. Second degree operator plus, and keep going in this way up to r times r minus 1 up to r minus n minus 1 divided by n factorial multiplied by delta to power nf sub 0. So this is forward Newton. And we said forward. This is the word forward difference. Because delta Fi equal to Fi plus 1 minus Fi. This time we go forward. The next one minus the current one. Because we have backward, which is the current one minus the one before. So forward, it is the next step minus the current step, or next value minus the current one. But the backward will be the current one minus the one before. And R is defined by as x minus x sub 0 divided by h. Let's have one example for this formula. Let's say the upward velocity of a rocket is given by this we have time in seconds. We have velocity, say v given in meter per second. We have 10, 15, 20 second, and 25, 230, 360, and it's 520, and 680. We need to use the Newton's method divide the difference interpolation to evaluate. T equal to 16 seconds. Okay, we need to apply the Newton divided difference. I can use the general form of the Newton divided difference, or I can use the new one if we have equally spaced values. In this example, we have equally spaced values. I have from 10, see this is 10 to 15 is 5, 5, and 5. So all what I need just to apply the new formula for when in case that we have equally spaced value. Solution. I have T and we have V. T is given by 10, 15, 20, and 25. V is 230, 360, 520, and 680. Since we have equally spaced values, all that I need is just to find the differences between the values without dividing by the difference of xi and xi plus 1. All that I just find the differences between the values of the velocity. So in the first case, in the first column, the difference between these two is 130. No need to divide by the difference between the x values because they are equally spaced. This is 5, 5, 5. So we're going to use the new formula. Now the difference between 360 and 520 is 160. Difference between 680 and 520 is 160. This is if I plus 1, the next one minus the current one. Next one minus the current one. Now this is the first difference or differences. Second one, I need to find the differences between these. 160 minus 130 equal to 30. Difference between 160 and 160 is equal to 0. Third one, delta to power 3, or the third. 0 minus 30 will give me minus 30. This is the last one. Now I need to find R. R is given by x minus x0 divided by h. X is the given value in the problem, it is 16. I have x equal to 16. x0 equal to 10. And h equal to 5. It is the difference between the x values. It's equal to 5. So R is equal to 16 minus 10 divided by 5, which is equal to 6 divided by 5 is equal to 1.2. This is R. So the polynomial now is given by B3. Is equal to f sub 0 plus delta f or R plus R times R minus 1 divided by 2 factorial second difference operator 0 plus R minus 1 R minus 2 divided by 3 factorial third difference. By the way, because we didn't define this one, when we say factor n factorial, means n multiplied n minus 1 multiplied by n minus 2 can go on up to 2 times 1. This is the definition of the factorial. So the polynomial will be written as f sub 0, which is equal to 230 plus R is 1.2 multiplied by the first difference, which is equal to 130. Plus 1/2, this is 2 factorial, times 1.2. R minus 1 will be 0.2. Multiplied by the second difference, which is equal to 30. Plus 3 factorial is 6, so it is 1 over 6 multiplied by 1.2, 0.2, and minus 0.8. 1.2 minus 2 is minus 0.8 multiplied by the third, which is minus 30. So this is the given polynomial. should be, okay, this is the polynomial. And the second one is the value of this one. This is B3 or B at 16. So the polynomial is given by f sub 0 plus r delta f sub 0 plus r minus 1 delta square divided by 2 factorial plus r times r minus 1 r minus 2. This is the general form for the polynomial because r is a function of x. If we replace x by 16, I will get the value which is b of 16. So the v of 16 is approximated by v 3 of 16. It's given by this value. We need to apply use the calculator to find this one. This is 230 plus 12 times 13 is equal to 156. Plus that will be 15 times 1.2. Okay. 0.5 multiplied by 1.2 times 0.2 times 30 equals 3.6. Plus, let's say, that will be 1.2 multiplied by 0.2 multiplied by 24 divided by 6 equal to 0.96 plus 3.6 plus 156 plus 230. So this is equal to 390.56. So this is the approximation value for the velocity of the rocket after 16 seconds. And you can see 16 position. So the expected value will be between 360 and 520, and it was given by 390, which is okay.